Hey everyone, Miss Jack here, and today we're going to be talking about net force. Now, you may be standing up or sitting down right now. Net force just means the sum of all forces acting on an object. So if you're sitting down, you are pushing down on your chair, and the chair is pushing back up on you. And those are equal or balanced forces because you're not moving, right? If you were pushing down with more force, you would push the chair into the floor. If the chair was pushing up on you with more force, of course, it would be lifting you up. So get out your notebooks or a sheet of paper so you can follow along, take some notes with me, and we can learn about net force. Here we go. Title your page, net force. So we have different things we want to consider when we're talking about net force. The first thing, we're going to go ahead and define net force because that's what we're going to start off with. Net force. And what do we say that was? The sum. What does it mean when we see sum? Just the total, right? Total, we would add the sum of all forces acting on an object. Okay, so we have two different instances whenever we have forces. We can add up the sum, and they're either going to be balanced or unbalanced. So, I'm going to change colors. Y'all know I'm extra like that. Forces are balanced when do you think they're balanced? So that's just like you sitting on the chair, right? So there's no change in motion. Or the net force is equal to 0 because the forces are balanced. You're pushing down on the chair with the same amount of force that the chair is pushing up on you. The other instance is when an object is at rest, right? So if you are just sitting there, you're at rest, the forces are balanced. Another instance is when an object is at a constant speed. Constant speed, what does that mean? They're at the same speed. So like if you're in the car, you're driving on cruise control, that is a constant speed. So we can be moving when we have balanced forces, but it has to be at the same speed because balanced forces means that there is no change in motion. So it's just doing the same thing over and over. So if you're driving in the same direction on cruise control, then that would be balanced forces because there's no change in speed, no acceleration like we talked about before. So we can say no acceleration. Okay, so now forces, we're going to talk about when forces are unbalanced. So here we go. Y'all know I changed colors again. Forces are unbalanced when, okay, so when do you think forces are going to be unbalanced? So if balance is when there's no change in motion, unbalanced forces is going to be when there is a change in motion. So this is there is a net force. So it won't just be 0. Also, there's going to be, that one says no change, so this one is a change in motion. And then also this one's no acceleration. So remember, A change AC, if you remember from the last video, acceleration is present. All right, so now let's try to do a couple of problems, okay? So you can write these examples with me. Our first example, I'm just going to draw a line. So you can continue on the page if you're writing along with me, or you can continue the next page wherever it fits. Example 1, here we go. When we have opposite arrows, so what that means, our arrows are going to represent our forces. When we have opposite arrows, like if I have a box here, and I have one arrow going this way, and one arrow going this way, and let's say they're both, let's say this one's 400 newtons, so I'm going to put it in there. Newtons is just a measure of unit of how we measure force. So this one's 400 newtons that way, and this one's going to be 300 newtons this way. So now, what is our net force, the sum of all forces acting on this box? What are we going to do? Opposite arrows, we are going to subtract. So the sum of forces here would be 400 minus 300 is, that one was easy, 100 newtons. Now we also got to think about which direction it's going to move. So which direction has the most force? Our 400 moving this way. So we're going to say our 400 to the right. So 400 to the right, 300 to the left, the sum or the net force is equals 100 newtons, and we'll just put right. So it's going to be moving to the right. All right, next example, example 2. Now we're going to see if arrows are moving in the same directions. Same direction. Okay, arrows going, we'll just say the same way. Arrows going the same way. So again, we're going to draw our box. And now we have 2 arrows. I'm just going to draw the arrows like this. And let's say they're both 300 newtons. So that's like if 2 people are trying to move this box and they're both pushing on the same side in the same direction. So if they're going the same direction, same way, we're going to add those forces. Make sense? Okay. All right, so our net force here, 300 plus 300 is, that one's easy too, 600 newtons. Now which direction are we going? 600 newtons left. Okay, let's try one more problem. Okay, example 3. So we're going to do opposite arrows again. What do we do with opposite arrows? It's right up there. Subtract. Okay, so here we have a box again. And now we're going to have our arrows going this way. Opposite arrows again, same way. But now we're going to do 250 newtons, 250 newtons. So now we're subtracting. So our net force equals, subtract 250 minus 250 is 0 newtons. So what does that mean when we have 0 newtons? Look back over here. Our forces are balanced, which means our object, there's no change in motion. So this object here, if it's at rest, then it's going to remain at rest. All right. So what do y'all think? Do y'all feel confident in net force? Okay, well, those were some examples. Hopefully they helped you out. And now you can move on knowing how to calculate net force and to know the difference between balanced and unbalanced forces. Thanks for watching, and we'll see you next time.